Thank you for tuning in to This Automation Life, brought to you by Brenner-Fiedler. I'm your host, Jeremy Schubert. Each week we discuss technologies used in automation. This week, Ken Kloman, Pneumatics Specialist and Sales Manager with Brenner-Fiedler, is here to discuss vacuum applications. Thanks for joining us today, Ken.
Thank you.
So how's vacuum used in automation or machinery in general? I think most people probably think of their vacuum cleaner at home.
There's quite a few applications. In the automation world, there's a lot of pick and place applications.
Okay.
There's a lot of OEM applications for air sampling, testing, what perhaps the breathing air situation is in a parking structure.
Okay. Looking for like fumes from cars or whatever, make sure there's enough ventilation.
Correct.
Okay. Cool.
And then there's also all these hospitals and whatnot all have central vacuum systems for all kinds of vacuum use applications.
Okay. I think I've seen they can plug into the wall and hook up some device to it. And
Correct.
so there's piped, just like a normal place has electricity pipe, they also have vacuum piped around.
Yep.
Okay.
Almost like water or nitrogen or anything else they use.
Okay. Gotcha. Okay. So it sounds like there's so many things you could use vacuum for. How's vacuum created?
There's quite a few different ways. There's a what they call a venturi or a vacuum generator,
Okay.
which actually takes compressed air, drives it through like almost like a manifold, and has a port on the side, almost like when you're driving your car and you put your window down. You can feel the vacuum.
Yeah, okay. Huh.
And then there's also different technologies like rotary vane, diaphragm, rocking piston, claw, dry screw.
Okay. So these are all like a vacuum pump type of thing that would...
Correct, with
okay,
motor.
standalone. Okay. Okay, and so these have a motor on them. I assume that means they come in a lot of different sizes, voltages, things like that.
Correct.
Okay.
DC, AC,
Okay.
brushless. The venturi is actually no moving parts. The one that uses just compressed air driving through it. So that's usually for smaller applications.
Okay. And so I think I've seen stuff like that connected to like a suction cup, and it's like right above the suction cup on some kind of pick and place, maybe a robot or something else. Is that...
That's correct.
Venturi? Okay.
Yeah, they're usually in locations where it's too tight to put an actual pump in there.
Okay.
And the requirement is so small, you're not lifting a lot of weight, so you can get away with using a venturi.
I gotcha. And the idea is that having compressed air, like shop air, is a little more common than having like a central vacuum system.
That's true too.
Okay.
You don't have to have two, a compressor and a vacuum pump, just a compressor.
Gotcha. Okay. So when I think about that, though, if you're using compressed air to generate vacuum, there must be some trade-off. Is it less efficient from an energy standpoint?
It's definitely less efficient.
Okay.
It's about 4 to 1.
Whoa, wow.
Yeah. So, in other words, if you had a requirement for a 1 horsepower vacuum pump, you would need a 4 horsepower compressor to drive that venturi.
Wow.
Yeah.
That's a big difference, realistically.
And that's why it's always, if you notice, the venturis are always much smaller flow.
Yeah, so that makes sense why it's localized to a very small, like point of use type of thing.
Right.
Okay, gotcha. Okay, so if we're looking at some of the differences in the different types of pumps, you mentioned claw and rotary vane and rocking piston. Are there trade-offs? Are some of them used for certain applications, or like flow versus vacuum level type things? Or?
Yeah, basically the how you pick which type you're going to use is it really comes down to flow and vacuum level.
Okay.
The diaphragms are smaller flow, but they're quieter. Rotary vanes can be small to large. On the rotary vane side, there's oilless, which doesn't go to as high as a vacuum. If you get a rotary vane that's lubricated, it will go to a deeper vacuum because that oil acts as a seal.
Okay, that makes sense. I can picture that. All right.
The rocking pistons, are really kind of a medium size. It's the newer version in the marketplace. They're good for OEM medical applications. They're smaller and lighter than the rotary vanes. And that's kind of a piston diaphragm mix.
Okay.
That creates the rocking piston.
Interesting.
Then there's, on the larger side, there's a claw pump, which is oilless. It maxes at about 28 inches of mercury. If you need deeper than that and you want a oilless pump, you can go to the dry screw type pump, and that goes to deep vacuum, and it's oilless.
Wow, okay. So that brings up a couple other things. You mentioned inches of mercury. Whenever people are talking about vacuum, is that the most common unit, or are there other units that people will use?
There's other units. You can go to torr, which is, usually you're talking very, very deep vacuum.
Okay.
There's microns. Inches of mercury is mostly in the industrial world.
Okay, so maybe different industries, and I assume it's always the U.S. is different than Europe. I guess in Europe they'll probably use one, and then we use another here. And is that?
Yeah, but like aerospace will probably talk torr, and it's just
Okay.
how deep of a vacuum you have to go to.
Okay, I gotcha. And then you mentioned another thing, oilless versus lubricated versus non-lubricated. So I'm picturing this is inside the actual pumping chamber. What are some benefits to not having oil in there?
Well, just like your car, when you have a lubricated pump, you have to change that oil like every 500 hours in these type of vacuum pumps. That's on the oil sealed, but they also make a once through oiling system, which means it's basically the oil lubricator sits on the top of the pump. It goes through, it's the rotary vane type, and it ends up in a jar on the opposite side. And so with that, you always have to make sure that lubricator has oil, and then you're always dumping the oil on the other side. So some of the advantages of going oilless is you don't have the maintenance of dealing with that.
I imagine there's no Jiffy Lube for automation equipment out
That's
there.
correct.
So you're stuck changing the oil yourself.
And not only that, if you use the wrong oil, it can be a disaster too.
Oh, really?
Yeah.
Oh. What kind of problems does that cause?
If it's too thick, it doesn't get through, or if it runs too hot, the oil won't. It will become kind of
cooks or like smokes on.
yeah,
Okay.
kind of muddy.
Okay. It's just like using the wrong oil in your car or cooking with the wrong oil. You're not
Correct.
going to get what you wanted. Okay. Cool. Somewhere back there, you talked about this dry screw. So this is really, I'm picturing like two screws coming together, and somehow the threads of the screw essentially create the vacuum.
Correct.
Okay. And when you say like it goes to a higher level of vacuum, what are we talking about? Like what's the most you can expect out of a vacuum pump?
I believe it's like 10 to the -4.
Okay.
In torr.
And torr. Okay.
Which is almost.
It's a perfect vacuum
Space.
The space in outer space is there a number for that, or is it some crazy number? Okay.
Yeah.
Um,
All I can picture it is the deeper vacuum you get. If you picture a box and with having molecules in it,
Yeah.
the deeper you get, the less molecules you have, and you can get down to where you're hardly seeing any at all.
Okay, so now I'm picturing with this box, if you're pulling out individual molecules versus pulling out air, the air or whatever you may be pulling through a vacuum pump would act as like a cooling system, but when you're pulling molecules, there's nothing to cool. Just like I know that there's that problem in space. Is that a problem with vacuum pumps?
No, actually, like all these vacuum pumps can be deadheaded, which means you can leave them on pulling whatever they're pulling on, and they can run all day. And the thing is they all have a maximum vacuum. So if you think back to that box with the molecules, each pump that, goes to a certain level is going to pull out that number of molecules, and that's the best they can do.
Okay.
So if they leave 20 molecules in the box, no
Yeah.
matter if you leave that pump on the rest of the day, it's still going to leave the 20 molecules in.
Okay.
Whereas the next pump that might go a little bit deeper may get the next 10 out, and now you're at 10, but that's the best it's going to do. It doesn't matter if you leave it on all day; it's not going to get more.
Okay. So a lot of them may pull, may not go to a deep enough vacuum where that's an issue. They may have designs where they know that there's going to be almost nothing actually coming through, so they're able to cool in other ways. Okay.
Correct.
All right, that makes sense. Okay, so you mentioned flow and vacuum level. What does somebody need to know in order to get the right vacuum pump or generator?
Yeah, I mean that really decides a vacuum pump. That is what you have to know is the flow and the vacuum level.
Okay.
And how you can do that is there's flow meters out there
Okay.
that can test the flow, and there's a lot of different vacuum gauges and obvious, that go inches of mercury, torr, microns, whatever you're looking to get.
Okay. Is there, if you don't have access to a vacuum or to a flow meter, are there other options? Can you oversize and?
Yeah, that's the nice thing about vacuum is you can always oversize. It's not going to hurt the pump to run at a lesser number, because again it can run all day and it won't bother the pump.
Okay, cool. Well, that's all the time we have for this week. Ken, thanks for joining, and thanks to all of you for listening to Brenner-Fiedler's This Automation Life. If you have any questions about what you just heard, or if you have a topic you'd like to hear discussed, please email us at tech, that's TECH, at brfa.com. And be sure to continue tuning in each week. In upcoming episodes, we're going to talk about some communication protocols, and I think we're going to get into some more pneumatic.